Hi, I'm Curt Frye. In this video, I would like to continue my exploration of the traveling salesman problem. And for this, I will have multiple drivers with equal stops, but that start from different locations. So that means that I need to modify the standard solution we've been using in other movies. If you would like to follow along, and I encourage you to do so, you can download the sample file tsp_different start using the link that I provide in the video description below. In this workbook, I have 14 stations that I want my drivers to visit, and I have them starting at station number 15, which is at coordinates 13, 17 on the route map on the right. This map is not in any sense optimized. I just have the values 1 through 14 for the 14 stops in numerical order, so you can see how the solution changes what appears on the map. And the lookup here for each of the positions on the two routes, I have the X and Y coordinates separately, are used to create the XY scatter chart with connecting lines plot over on the side. I also have a distance matrix that gives me the distance between each pair of stations. If I want my second driver to start from a different station, then I need to add it to the station list and update all of the formulas. And I know this can be a lot of work and take a bit of time, but it's important to see how the process works so that if you are using this in your own business, then you will know exactly what to do and don't have to try to come up with the solution on your own. So I have station 16. I will add it to the station list by selecting A16 through C16 and then drag the fill handle down. That copies down the formatting, and now I can add it. And let's say that I'll put it at 35 and 13. So it'll be station 16. The X coordinate will be 35 and the Y coordinate will be, I think I said 13. Yeah, we'll do that. Now I need to add the measurements to the distance matrix and also refer to the entire table here. So I'll start by working with the headers. So I will extend 14 and 15 to include 16 using the fill handle technique. Same thing for the column headers. And now I want to edit the distance calculation formula here in cell G2. I'm currently looking from A2 to C16. I actually want to go to C17. So I will update that in all four places here. So C17, then enter. The calculation didn't change. That's good. And when I copy it down using the fill handle again, none of the other calculations changed either. So that is a good thing. And I will drag over to the right until I cover column V. And everything looks good. All of the diagonals match, 17 to 17, 10 and 10, 36 and 36. And also I have zeros on the main diagonal from the top left to the bottom right. I want the second driver to start from position 16. So I'll click cell C21, type 16 and enter. And of course, I get a reference error because that is beyond the limit of the original lookup, so I need to update these formulas as well. So I'll click cell D22, and instead of U16, I am now looking at row 17 and column V as the bottom right corner of the distance matrix. So instead of U16, I'll change that to V17 using a $sign so that the reference remains absolute and unchanging when copied. Press tab, do the same thing for the next cell over. The $17, I can see the reference is correct over here. Press enter, and there we go. And I can select cells D22 and E22, drag down until I cover row 29, and there are my distances. I need to end the second route at 16 as well, rather than 15. Okay, I was wondering why I got the same distance for 1 and 2, and that's because I forgot to make that change at the end of route number 2. So that's a good thing to watch out for, and another reason to watch this thing the whole way through at least once. So there we have all of that, and then I have the map coordinates, which are provided here, and I need to update my lookups again. So this time, instead of going A2 to C16, we add the extra row down to C17, and I'm doing the exact same thing 4 times, so I won't comment on it. 17, enter, there we go. And then I will select cells A36 to D36, drag the fill handle down to cover row 44, and there we go. So I have 9 stops here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And up here I go 0 to 8, which is 9, so everything looks good. And now I can work with the solver model. So I'll go to the data tab of the ribbon, click solver. The objective cell I have highlighted in green, just so I know what it is, and that's in E32, minimizing the total value. Changing the variable cells, and those are B22 through C28. We're using the evolutionary engine, and we're going to be setting boundaries on our values. So I'll go to the options dialog, evolutionary tab, and we will require bounds on variables, and click OK. Now we can add our constraints, and they will all affect the yellow highlighted cells on the left. So I'll click Add, and then cells B22 to C28 must all be less than or equal to 14, because those are the stations that are going to be visited by our drivers after they leave 15 and 16 respectively. Add. The same cells must be greater than or equal to 1. Add. And they must all be different. So select the same cells, B22 to C28, and the comparison operator is actually diff, which stands for all different, and click OK. And that is our solver model. I can click Solve, and I will come back when Excel hopefully finds the solution. Okay, Solver has returned a result, and I'll click OK. And scroll down a little bit so we can see our 2 different routes. And it looks a little bit different from the solutions that we've seen in other movies because I had them starting from different points. But I can see that I have very nice circles, or very nice routes, and it appears, at least just from looking at it, that this is probably a close to optimal solution. So there's that, and it appears that our model has worked correctly. I also created a model for 3 different drivers with an equal number of stops. So I'll click the 3 equal tab and go down, and here I have our 3 maps. Even though they overlap slightly, Solver still found the solution, and it's the best it could do given the constraints that we provided. So take a look at the solution and compare it to what we did for the 2 equal worksheet, and hopefully you will have a great deal of insight into drivers leaving from different locations, and you will be able to create your own for 4, 5, or even more drivers. The one thing I will point out is that I have the 3 stops, or rather the 3 different starting points here in the station list, and everything else was just a variation of what I did earlier in this movie. I hope you got a lot out of this explanation, and you can use it in your own business. If you enjoyed the movie, please like it and subscribe to my channel.